Welcome back, Idiot Squared viewers. This week, we have another installment of Observer Theory, where we are going to try and disentangle or unravel what an observer is, what does it mean to make an observation. We're even going to get into the measurement discussion. This could completely blow up in our faces. We could end up rambling about nothing. I cannot guarantee you we'll make any meaningful progress, but we are going to give it a hot try. So we've got a little bit prepared, but not much. So strap in, buckle up. We're going on a wild ride. Polska, you ready?
Yo, fuck yeah, I'm ready, dude. Jeffrey Epstein's still alive, so you hear that?
No, I did not hear that.
Megyn Kelly's saying that Jeffrey Epstein is still alive, so
fascinating. Okay, that flight log or whatever got released. That's pretty funny. The old Stephen Hawking stuff. We might have to reserve that for another podcast, though. Let's jump straight into.
Absolutely. Sorry, guy. I just wanted to fuck with you a little bit. But yo, legit though, Megyn Kelly did like say that. Like, there's a clip of her saying that he might still be alive, which is hilarious. But anyways, yeah, like you said, guy. We'll talk about it in another pod.
It's possible. Okay, so last pod, I think it's going to be the last pod, we discussed observer theory and the blog post that Stephen Wolfram wrote. Then we had a comment from one of the viewers about sensory citizenship, and we discussed that and how culture, where you are, the memes of the time, all of those things can influence your perception and sensory perception of the world, tastes, preferences, likes and dislikes, that kind of thing. And now we're going to dive a little bit deeper. So we'll intro it off with a little bit of the Wolfram stuff, and then we're going to discuss what various thinkers on this matter have said. So we've got Carl Friston, Dr. Michael Levin, and Neil Seth, and some others that we will then venture into. So to kick it off, we'll just do the brief overview. Stephen Wolfram's observer theory offers a profound perspective on the nature of observation and its critical role in shaping our understanding of the universe. Some key insights that are quite profound. The central role of observers. The theory emphasizes that observers, through their perception, measurement, and analysis, play a crucial role in defining the fundamental laws of the universe. The observer's nature is not just a passive recipient of information, but actively shapes the interpretation of the world. Equivalencing and computation. Observers simplify the complexity of the world or universe into a reduced representation suitable for finite minds. This process, called equivalencing, is central to the theory. It involves aggregating vast data like photons or molecular interactions into a manageable format. This process is inherently computational, indicating a deep connection between observation and computation. Sensory and measurement processes. The theory explores how our senses and technological measurements work, highlighting that they primarily aggregate small inputs to produce an average or discrete output. This aggregation is a form of equivalencing, where different inputs are treated similarly to reach a coherent conclusion or observation. Constructing reality. According to the theory, our perception of reality is a construct based on how we, as observers, sample and interpret the world or universe. This concept extends to quantum mechanics, where the observer's role is crucial in transitioning the quantum to the classical description of events. Abstract observers and metamathematics. The theory also applies to abstract domains like mathematics, where observers sample from a mathematical universe of potential axioms and theorems. This demonstrates the unification of physical and abstract observations, underscoring the universality of the observer's role across different realms of knowledge. These insights underscore the profound impact of the observer in not only interpreting, but also shaping our understanding of the physical and abstract universe. This theory potentially advances our comprehension of the interplay between observation, computation, and the nature of reality. That was fun. But yes, I tend to agree with those things. It's a fascinating exploration. And I like the fact that Wolfram, I like how he's got here, and I am excited to see what he can contribute and or unlock for us to further our understanding of things. Was there anything in there that piqued your interest, or are we okay to continue?
I'm just so blown away by the fact that this is all like this. This is essentially a controlled hallucination, right? That we're all experiencing together. It's just like, just thinking about that just blows me away. And then I was thinking, okay, if I'm looking at like a cup, right? So my mind is sort of creating that cup. But then again, that cup is also real in a sense because it's there. And my brain, working as a prediction model, is sort of designing how I'm perceiving that cup. So are both things correct? Am I having a hallucination of this cup and the cup is also in existence? So sort of like my brain is connecting with the universe simultaneously, or am I just inventing everything? Do you know what I'm trying to get at?
Yeah. This is the deep philosophical things. But yeah, so to briefly answer your sort of question there, from my perspective, or my reference frame, or my limited understanding, essentially what's happening is your version of the cup that you're hallucinating, right? That object is a way to interpret the processes that make up the cup, right? So at one level, you can say the cup is real, right? But that's just a convenient coarse graining of the many processes that is the universe in that form, representing as the cup, right? So is the cup really a cup? Well, based on our definitions, we say yes, but that's just a coarse graining, right? At the underlying level, that cup is made up of what? Like it's clay, right? Clay is made up of different molecules, right? Those molecules are made up of different atoms. Those atoms are made up of different combinations of quarks, right? All the way down to the Wolfram level, which is like, there's a bunch of hypergraphs going on, and they are persisting in a sort of in a loop, right? Or they're like they're in a repeating process, right? That allows them to have persistence over time in that form or in that arrangement of processes. Okay, so we don't see all of those processes happening. That's at the low level. There's like, trillions, zillions, bazillions, like insert large number of processes happening. But that's too computationally intensive for us to see. So we just coarse grain it and we say, oh, that's just a cup, one thing, right? So we take all of this crazy complexity that's happening and we say that it's a cup. And that works really well for us because we are like bounded computationally and we are finite in extent, right? We can't see all of that underlying dynamic, but it doesn't mean that there isn't all that underlying dynamic. So there's many different ways to describe that cup, many different levels. But for us, the convenient level that's worked well for us as humans to exist on this planet is to just say that's a cup. Does that kind of make sense?
Yeah, it does. It does actually. So something about that cup exists. It's just the way that I'm hallucinating it. I perceive it as a cup.
Yes.
That's crazy. That's crazy.
Because it's convenient to do so, right?
Yeah, exactly. Yeah.
Yeah. So it approximates a truth about a thing, if that kind of makes sense.
Yeah. Yeah, we've talked about this so many times because like if we were to zoom into the cup, it would look completely different.
Yeah,
right.
That's right.
So
yeah. Good question.
Yeah.
So unless you have anything else, we can jump into some of the other great thinkers on this subject and get a little bit more of an exploration.
Yeah, let's continue, guys. Continue.
Okay, so exploring other theories of observation from various thinkers can reveal a diverse range of perspectives. So we can go through and summarize some of the concepts from these thinkers, along with Stephen Wolfram's view for comparison, right? So we can do a bit of a compare and contrast between some different views on this. So Carl Friston, very famous in this field of the active inference circle, which is a promising model. Yeah. So
what is active inference?
Active inference is a theory. Okay, so what is active inference? Active inference uses Carl Friston's free energy principle to sort of work on what an observer is. If that makes sense. So it's essentially saying that an observer is actively inferring things about the world. All right, it says that the observer has a predictive model, right, which is what you just said about the hallucinating a cup. Your brain, nervous system, or body is hallucinating that there is a cup there. That in their framing, that would be that is considered, to be an active inference, right? You're actively inferencing the world or the universe.
Yeah, I have something short here. Active inference is a way of understanding sentient behavior, a theory that characterizes perception, planning, and action in terms of probabilistic inference. Okay, what the fuck is probabilistic inference now?
Probabilistic inference. That's the same. It's the same thing as
probabilistic
equivalency.
Oh, good thing I'm an idiot.
Yeah. So essentially, it's very similar or analogous to Wolfram's equivalency, right? So like there's all these crazy things happening, right? But we can't follow every single one. So we look at it like sort of probabilistic and be like, okay, this is a good enough way to interpret that, right? Or this will work for our purpose. Okay. So Carl Friston, a neuroscientist and theoretician. Friston is known for the free energy principle and active inference. In neuroscience, his work focuses on using physics-inspired statistical methods to model neuroimaging, data, and other random dynamical systems, suggesting that observation in neuroscience is deeply intertwined with understanding brain functions and their underlying statistical dynamics. Now, one quick thing to pick on there is the random dynamical systems. In Wolfram's conception of this, there is no truly random. The universe is deterministic. But because we are computationally bounded observers, we perceive things that are of equivalent computational ability to be random, right? So his famous example of this is the Rule 30 cellular automata, which cannot be, you can't predict ahead of time, even though the rules that start the automata or that the automata is made of are very simple, right? You can look at them and think like, okay, that's very simple. How could that produce complex behavior? But it does. And it's seemingly random. But what he says is with the principle of computational equivalence is that anything that appears random or, is not simple or cannot be predicted is essentially doing as complex computations as you are, if that makes sense. Hence why you can't predict ahead of time. That kind of makes sense?
Right. Mm-hmm. Yeah.
So there is, in Wolfram's model, there is no true randomness. There is just things that are doing, equivalently complex computations as you or as the observer is. Okay, so we can dive in now. So Dr. Michael Levin, we've covered him before with his biology stuff. Fascinating. He has the technological approach to mind everywhere, TAME, which says that, we are made up of various levels of observers, right? So our cells are these little agents, conscious beings, and it could go all the way down to atoms. We don't know yet. Anyway, so he is a developmental and synthetic biologist. Levin's research encompasses bioelectrical signals, basal cognition, and top-down control of form and function in biology. His work on xenobots and bioelectricity highlights how observation in biology can be understood in terms of cellular communication and the dynamic needs of organisms, particularly in development and regeneration. So in Levin's conception, we are made up of, billions, trillions, quadrillion, trillions of observers or little agents or little things solving little problems in their morphospace, right? So again, we discussed at different scales, the universe is going to look vastly different, right? So the cells have little problems that they're trying to solve, and by them solving those, at a large scale or at this, coarse graining, they sort of group together to create an organ. Those organs, collectively solve a problem. That organ solves a problem for the entire body, so on and so forth, right? Yeah, makes sense? No?
Yeah, no, I'm following. I thought you had something else to say.
I do. Okay, so Chris Fields. So Levin and Chris Fields work together. Chris Fields he has an interdisciplinary approach that spans physics, especially quantum information theory, developmental biology, and cognitive science. He focuses on how observation is a process of extracting information from the environment, emphasizing the interdisciplinary nature of understanding observation across different scientific fields. So Chris Fields talks about what it means to make an observation and how, in order to observe something, you have to be entangled with it. And that intrinsically leads to some sort of bit of murkiness in a sense, because when you become entangled with something, you can't disentangle you can't easily disentangle it, right? So you can't sort of tell what's affecting what, right? It gets into this sort of strange loopiness.
Because you've gotten too close to the problem?
Because you're entangled with it, right? So the technical term is escaping me right this second, but because you are, in order to make an observation, you have to become entangled. But because you're entangled, it's sort of, I want to say limits.
Is it affecting the result?
Yes, that's right.
Whatever you're observing?
Yeah, it's sort of murky's the water. Like you can't cleanly disentangle it, if that makes sense. So you can't sort of...
Yeah.
Yeah. We'll get into this as we
a weird example.
Delve. Go for it.
Okay, I just wanted to bring up this weird example to see if I'm on the right track. So if we just think about science, right? And you're observing a group of people's behavior, and you have them in a laboratory type setting, that's going to be affecting their behavior because they know they're being observed. And if you're in the room with them, they know that you are observing them. So then it's likely that entanglement with the experiment is going to, have an effect on the results.
Correct. Yes, that's a very good example. That highlights the sort of that murkiness, that inability to untangle whether or not this is what is probably a simple way to say it is you can't definitively say this thing is exactly this thing, because when you're entangled with it, you're forcing it to be in a certain way. That kind of makes it sense. Like what you just said with your example of observing people, they know they're being observed, so it's going to change their behavior. So that exists all the way down, so to speak. So you can't disentangle the interdependence, which means that you can't sort of say anything for certain. You can only say it based on the reference frame.
So what does that say about behavioral neuroscience then?
What in relation to? Give me a bit more
just
there.
Just observing, doing experiments on certain hypotheses of observational psychology, behavioral psychology, or neuroscience, where we're trying to get a better understanding of how the brain works. So, for example, if we're looking at marketing, if a company releases a new campaign or a new marketing campaign, they're going to want to test it, how it works on an audience. So if you have if you're testing it on people, they know that they're being tested. And a lot of the times, maybe there's questionnaires at the end, right? How did this make you feel? Did you notice this? And the patients, or not the patients, the participants in the study usually would have to fill out, something. And then there's that there is that bias, or there's bias, and there's also the you're relying on participants to be truthful. So that's like another limitation of those types of behavioral studies, right? So in the world of neuroscience, because it's heavily like behavioral science is heavily based on those types of experiments where you're likely interviewing people. We do use brain scans, right? But we don't have a deep enough understanding of the brain to really conclude like what some of these brain scans might be telling us. I think there's a lot of pieces of the puzzle missing. So we do heavily rely on, self-reported data, which is not very good.
Yeah. So I think what it sort of illuminates there is that how difficult it is to, or possibly if that might actually be, it looks as if it's actually saying it's almost impossible, right? Or it is impossible to actually get concrete, definitive answers about things. All of those answers will be dependent on the reference frame and the way that it was gone. There will be inherent biases, there will be inherent influences that can't sort of be cleared out, or that can't be taken out, right? So you can't get this truly objective measurement or observation. Measurement, I'd say. Or observation, yeah. Can't disentangle the two right this second. But I think that's what it's pointing is. It's like you can't ever get truly accurate, right? Or if that's even the right, I don't even think that's the right word to use. But it's showing the inherent limitations. That's probably the simplest way to say it. There are inherent limitations to all of these things. We can't necessarily get definitive answers. They're always going to be based on some reference frame, and there will be some of that ambiguity that can't be disentangled. It can't be taken away. Okay, so we'll do a little overview of Neil Seth, and we'll bring up some Bernardo Kastrup, and then we'll tie this all back together. So Neil Seth, a cognitive scientist. Seth views conscious experiences as a controlled hallucination and perception as informed guesswork. He posits that our experiments of the world and ourselves are product of the brain's best guesses, suggesting that observation is an active, brain-driven process that constructs our reality. Very analogous to Wolfram, very analogous to Friston, very analogous to Chris Fields, right? That's that entanglement, right? Okay, so Bernardo Kastrup. Kastrup emphasizes the role of consciousness in observation, particularly in quantum phenomena. He posits that conscious observers are essential for the measurement and manifestation of physical reality, suggesting that the material world is fundamentally underpinned by a transpersonal mind. He thinks that the universe is consciousness, and that we are sort of like little entangled subsets of that experiencing itself.
Can you try and elaborate on that, Roops? To an idiot? Because I'm trying to wrap my head around that one. Like the universe being conscious, because I can only sort of create the concept of consciousness as I perceive it, right? Like being alive and hallucinating the world. So could we say the same for the universe? The universe is also hallucinating the universe?
Yeah, in a sense. I'm sure you can. You have like the holographic principle with, the black hole stuff, where all the information about the black hole, the three-dimensional volume of the black hole is encoded on the two-dimensional boundary, that holographic principle. The universe being consciousness. What he's saying is, consciousness, like the entirety of the universe could be consciousness. At the base level, it is just consciousness, and we are some entanglement of the various levels of consciousness, or different aggregations, or different combinations of those conscious processes. And the sum total of that gives us our consciousness, our perspective on the universe. I don't know if that does justice to what you're asking, but this ties into what the Wolfram stuff is exploring.
Yeah. So like the hypothesis is sort of derived from, if consciousness is entangled and humans have consciousness, therefore the universe must have consciousness as well.
Not so much. I think he's got huge amounts of like hundreds, maybe thousands of hours of podcasts and content on this stuff. It's a lot deeper. He typically uses some fantastic words and a bit of, like, I find it quite poetic the way he speaks. But I think, no, what he's really getting at is he's saying, like, we want to try and say the universe is made up of matter, right? Like it's a physical thing. His thing is, no, the universe it's pure consciousness, right? And so you could say that could be analogous to the space of possibilities, right? Like the universe is all that's possible. And so his thing would be that that base level is just consciousness, and then from that, the different ways that consciousness can interact with itself, causes particles to arise, molecules, collections of molecules into larger things that end up making us the way that we are. But his thing is, everything in the universe is conscious. Again, we got to understand this. It's like there are obviously levels to this, right? We are a specific entanglement instantiation of processes. We're a specific combination of all of these different processes happening across all these different scales. And that sum total is what we experience as our consciousness. But if you tie in what Levin and Chris Fields and their work shows, is that it's not just you that's conscious, right? Your organs are conscious to a degree. Your cells are conscious to a degree. They're trying to solve problems in their space, right? And again, at the varying levels, the universe is going to look very different to different things, right? Based on the sensory apparatus of those things, but then also based on the scale of those things, like at what level do they exist? We've discussed this before, but when you zoom into an atom, right, the atom is like 99.99% empty space. You have the nucleus, and then you have the electron shell that's moving around, right? But the most 99% empty space. So the universe is going to look really different to an atom than it does to us, right? It's like in this tiny little bit of space here, there's so much going on in there. We just don't have access to it because we're having to do this coarse graining because we don't have the computational capacity or ability to effectively model all of those intricate dynamics, right? Or we might have some of that ability, but it's not useful for us at our scale, right? It doesn't really matter to us what's happening at this tiny quantum scale or it's almost quantum scale. It's more relevant for us. We sort of exist at a higher level.
That's true. Like, it does seem the entire body is conscious, because if you look under a microscope at like bacteria, like you see like bacteria attacking other cells or like eating other cells or injecting things into other cells.
They got to deal with their Karens as well.
Yeah, exactly. Like they're out about doing shit. You know what I mean? Yeah. Doing work, getting shit done. So when you're looking at that, you're like, it's like all this, everything's like alive. Everything, it does make sense for everything to have consciousness at some level there. That's really interesting. Yeah, like point that you said finally, it made a click in my mind that, like everything does sort of have a consciousness.
Well, potentially, like we don't, like this is what these guys are all converging to, in my opinion. That's why we sort of chose to explore these thinkers, because they're all sort of coming to this from different areas, but they're all converging to, like a similar sort of way of conceiving this. And I find that very fascinating when you have many great thinkers from various fields all converging on something. That to me is an indicator that there could be something of interest and value there, right? But yes, it's interesting to think about that. Like we are the sum total of all of these different processes, which have some form of consciousness, right? Some form of awareness or conscious. We'll stick with consciousness. I don't need to confuse anyone or myself any further. Some form of consciousness relevant to them in the space that they exist in, right? And if you stack enough of those together across the various scales, you can end up with this rich experience that we get to have.
Amazing.
It is pretty dang cool. Okay, so we're going to tie this back into Wolfram's observer theory stuff a little bit, and then we'll go on a bit more of an exploration. So Wolfram's observer theory posits that observers are critical in determining the fundamental laws of the universe, right? So that's a key point. He's saying, like, we sort of, for a long time, have taken for granted that the universe is, three-dimensional or four-dimensional with the time, right? So four-dimensional with time included. And that's how the universe is, right? But what he's actually saying and what he's getting at is, no, we perceive the universe to be that way because of the kind of observer that we are. It's just one way to interpret the universe, but it is not the only way. And it doesn't mean that just because we interpret it that way, that it fundamentally is that way. It's just how we perceive it to be, or we create it to be, or we hallucinate it to be, right? So different observers can have different laws of physics.
That's right. I remember we talked about this before.
Yeah,
and this made me just remember a question that Neil Seth posed at the end of this TED Talk that I watched before the podcast I sent you.
Nice, so he says, you did background research. Fuck yeah.
So who are you really? Think of yourself like the color red. You exist, but you might not be what you think you are. Yeah. Yeah, that's right.
Yeah. I
sounded cooler when he said it though.
Definitely.
But it's kind of going, it's in line with what you were saying though, right?
Yeah, absolutely. So like we perceive you perceive yourself to be Polskar, I perceive myself to be Ruben. And that's a convenient coarse graining. It's a convenient level of abstraction for us to do that. Because if we were to actually think of what we really are, all of those different processes, that exceeds, like that's, we hit buffer overflow, right? We don't have the capacity to simultaneously be this thing and understand every single intricate detail of all of the processes that make us up across all of the varying scales. So we pick a convenient coarse graining. And the beautiful thing about all of that is it leads us to get to this point where we're like, it's all convenient coarse grainings. And so to understand, to think that you are just one thing is a fallacy, right? So this kind of interesting thing that I like to, or I've been thinking about and sort of like to say in a sense is nothing is just one thing. Life is a beautiful spectrum of oscillations between what's possible or between the extremes, right? So, you can think of yourself as the human Polska, and that's one way to think of yourself. You can think of yourself as a collection of cellular agents, right, who are all trying to solve problems in their morphospace, and that sort of converges to being you. That's also another way you can think about yourself. You can think about yourself as a series of quantum processes. But as you go down, the number of things that you would have to think about to sort of encapsulate that space, increases and potentially exponentially, right? So you can't hold all of that. So we just pick this. It's easy to just say, you're Polska and you're a human, right? But yes, what you think you are, you might not be what you think you are I would say it's a true statement. We most certainly aren't what we think we are. We are vastly more complex than that, and we cannot hold that complexity to its totality in our minds. So we always have to come up with some equivalencing and coarse graining, convenient abstraction. And that's a beautiful thing that we can do. And I'm glad that we can do it. But I'm also glad that we can sort of push deep down and try to, I find that challenge helps to expand one's mind and one's capacity to think of things, right? Like you can sort of, you can increase the complexity of your mind, which allows you to conceive of more complex things in the universe, which gives you a deeper, more nuanced, sort of approaching in the limit, a more total conception of things. And I think that's beautiful, and it's a worthwhile journey to go on. Okay, so I'll finish this little Wolfram tie-in. Okay, so fundamental laws of the universe. It suggests that observation involves equivalencing, where complex inputs are reduced to simpler, manageable outputs suitable for a finite mind. This theory integrates the concepts of computational irreducibility and reducibility, asserting that observers are computationally bounded and that their experience represents a filtered version of external reality. So by comparing these views, we can see a spectrum from the mathematical and computational focus of Wolfram to the conscious-centric approach of Kastrup, Friston, Levin, and Fields. Provides perspectives grounded in neuroscience, biology, and interdisciplinary sciences, respectively, while Seth offers a cognitive and perceptual psychological angle. Each thinker brings unique insights into what constitutes observation, ranging from the brain's interpretive processes to the fundamental role of consciousness in shaping observed reality. So I would say it's not just interpretive, but it's that generative, right? The sort of, in some sense, our mind or our consciousness is a generative model, right? And that's that making the predictions, that controlled hallucination. So yeah, anything you want to hit on that? The next sort of thing we got teed up is the measurement.
Oh, yeah. Let's get into that. That's really interesting. You mentioned to me before the podcast that, was it Neil Seth that has come up with this, or was it somebody else?
No. So there is a guy who is famous for stealing moon rocks from NASA and having sex on the rocks, being the first person to have sex on the moon. And he has a very interesting story. He also does some really fascinating and interesting work. His name is Thad Roberts. You can just Google Thad Roberts and moon rocks or sex on the moon, and you'll be able to read all about that interesting story. But that is not what he should be most famous for. He has also done some fantastic work on physics, right, and some mathematics. And he has a project called the Physics Monastery. And he's written some cool books on all of this sort of stuff. He's also trying to figure out what the universe is. And he, funnily enough, uses Wolfram Alpha an awful lot, which is Stephen Wolfram's computational knowledge engine that allows you to do high-level maths and physics and a whole bunch of other stuff. Fascinating tool. Anyway, he sort of approached this, funnily enough, because he was in jail for stealing moon rocks from NASA and having sex on them. And when he was in there, he didn't just waste his time. He took it upon himself to try and deeply understand the universe. And he approached this from a really interesting sort of angle. And what he sort of teased out very clearly, he might not be the first person to do this, but he's the first person I came across to clearly articulate it in this way. But he says there are only fundamentally 5 kinds of measurement, right? We have time. We have length, we have charge, we have mass, and we have temperature. And actually, I can say this: he's not the first person, because these are Planck constants, right? So we have Planck time, Planck length, Planck charge, Planck mass, Planck temperature. So Planck did this. Stupid of me to say that before. Anyway, so he does this, and he then came to do all this sort of stuff, and he realized that there's a thing called derangements, right? Derangements. And if you have 5 things and you derange them, there are 44 possible ways to derange them, right? And when you do this and you combine them in various ratios of themselves, you actually get the constants of nature as we have recorded them. The 44 constants of nature. Right, which is fascinating, because you're like, everything all right there, guy? Getting broken into?
No. Mami, estoy haciendo el podcast.
Oh, good.
I'll tell you who that is after, guy.
Okay. So Fascinating stuff. Check out Thad Roberts. He has a YouTube channel, Thad Roberts. He's done a bunch of interesting stuff on this. Again, don't know if he's right, but it's just interesting. Okay, so we'll just do we'll deep dive into measurement, right? Sorry, did that make sense?
So, yeah, it does. But why did you say, so Planck was a scientist who came up with different types of measurements, or he was the one that stated that there's only 5 ways of actually measuring things? And then what's this guy who has sex on the moon? What's
Thad Roberts?
Neil Armstrong? Okay. So sorry, Seth?
Thad.
Did you say
Roberts?
Oh, Thad. Okay, but so was it Thad that just came to the conclusion that there's only 5 essential ways to measure things, or was it Planck? What did you mean when you said that was stupid to say?
It was Planck. It was stupid for me to say it was Thad was the first person I came across, because it's not even true. Like, I just conveniently forgot that Planck did that. So Planck came up with like the sort of limits, right? He's like, the smallest possible time that can be measured is this. That's the Planck time, right? The smallest possible length that can be measured is this. That's the Planck length. The smallest possible charge that can be measured is this. That's Planck charge. Then the smallest possible mass that can be measured is this, Planck mass. And then it's got the greatest possible temperature that can be measured is this, and that's the Planck temperature. So the Planck temperature is humongous. And what Thad did was found a way to sort of conceptualize this using geometry. And so he has some cool models about that. But I suggest people go into explore some of that stuff if they're interested. It's a whole nother subject, but he's come up with a very interesting way to sort of model all of these things. And like I said, if you derange 5, right, the number of fundamental measurements based off the Planck measurements, you get 44 constants of nature. And he hypothesizes that all measurements that we make as humans and observers that we are and that we care about are some combination of time, length, charge, mass, or temperature. And it can be numbers of, so you can have length squared or length cubed, right? And then you can put that with temperature, and that's like pressure, right? Or there's all these different combinations, and you can arrange them in all these different ways with varying amounts of each one. And that combinatorial explosion that you get is like all the measurements that we make and care about. Every measurement that we make is some combination of these 5 underlying constants, or, forgetting one or something like that, right? Very interesting stuff. Okay, so I'll jump straight into this. So, time, length, charge, mass, and temperature. According to his view, complex measurements across various fields of science can be broken down into combinations of these basic dimensions. This theory aligns with the idea that at the most fundamental level, the complexity of the universe can be understood through a few basic constructs. So we have the standard model of particle physics. In physics, especially in the context of the standard model, measurements often relate to fundamental particles and their interactions. Properties like spin, momentum, energy, and quantum numbers are crucial. These measurements require sophisticated instruments like particle accelerators and detectors. But if you tie that into what Thad's doing, fundamentally what you're doing is you're measuring some length, some time, some mass, some charge, some temperature of these things, or some combination of those things, to get that measurement, right? To make that measurement. So we can only sort of approach reality through these dimensions, or combinations of these dimensions. Okay, so astronomy and cosmology. Here, measurements often involve distance, luminosity, velocity through Doppler shifts, and time. Tools range from telescopes to observatories that detect electromagnetic radiation, gravitational waves, or neutrinos. So, fundamental level of measurement, physical constants. Fundamental physical constants like the speed of light, Planck's constant, and gravitational constant are key in defining units of measurements in physics. The redefinition of the International System of Units, SI, in 2019 based several units on these constants. reflecting a deep relationship between fundamental physical properties and measurement. All right. So this is also, you can tie that stuff back into the THAAD stuff for people who are interested. Okay. Quantum mechanics and uncertainty principle. At the quantum level, the act of measurement itself becomes a central topic. As epitomized by Heisenberg's uncertainty principle, this principle posits that certain pairs of physical properties like position and momentum cannot be precisely measured simultaneously, right? So there is always some inherent uncertainty, okay?
Heisenberg?
Heisenberg's uncertainty principle. So that can tie back into that Chris Fields, that entanglement stuff, where there's always going to be some uncertainty because you're entangled. You can't completely disentangle what is affecting what, or right. That also ties into this. Okay, quantum field theory. Here, measurements deal with fields and their excitations, particles. The concept of a vacuum state, virtual particles, and field fluctuations are central, requiring a rethinking of what it means to measure nothing or a vacuum. Now, key things to think about there, right? So the Wolfram's observer theory stuff says that we're always making coarse grainings because we can't observe the underlying complexity of the universe because we are computationally bounded observers, right? This also goes into what Fields was saying about that entanglement. This also goes into that uncertainty principle because we can't be completely certain because we can't model the exactness of those dynamics, right? But at various levels, it works good enough. So that's like at the relative, like at the high level that we sort of exist at, when we throw a ball, we can say, oh, that ball, went there with a high degree of certainty, right? Because of the level of abstraction that we're functioning at. But it's never, I don't know, the ground truth or something like that. That's one way to say it. But that last point about, rethinking what it means to measure nothing or a vacuum, in Wolfram's model, the vacuum isn't nothing. There are vast processes happening that are tying space together, that are sort of knitting space together. We perceive it as nothing, right? But it's not actually. There is an immense amount of computation that's actually going on to tie all that together. And he has some, hypotheses about dark energy and dark matter and those underlying processes sort of being that. So it's just fascinating to see how like all of these different thinkers are sort of converging on it, and it's helping us to change and develop the way that we think about the universe and perceive the universe, and understanding how much of what we perceive the universe to be is actually us imprinting those things or us generating those things because of the way we are.
Have these guys ever gotten together to do some sort of symposium or conference?
Friston and Wolfram did one on MLST, Machine Learning Street Talk. Great podcast as well. But unfortunately, because they weren't as familiar with each other's work as they possibly could be, they didn't get very far. So there was a lot of like sort of, missing the point to a degree. But I've often thought it would be just a fantastic thing. In fact, I even wanted to do this, call a podcast or call a platform Collider, where you just collide all these different great thinkers together and just see what amazingness could happen. But you would need many hours to do this, right? You need to really let everyone sort of get deep into it. And there's a whole bunch of other things that would have to align to really get that out. But no, to answer your question briefly, no, they have not all got together and done this, but I would love to see that. And maybe we should try and push to make that happen. That's a good suggestion.
I was going to say, God, Idiot Squared should host it.
Yeah. Might have to change our introductory email. Sell that to him.
Idiot Squared podcast with Wolfram Model, Neil Seth, Carl Friston, and who else?
You guys want to come and do a podcast with the guy that can't even remember your names? For sure. But just quickly, so Elon, we're fans of what Elon does. Elon Musk, that is. He he has his own sort of loose theory about this, which is like the universe optimizes for novelty, right? So the, sort of, and he's like, the most hilarious outcome will be the most likely. So in this universe, right, if that is true, maybe we are the fucking ones to do it, right? That would be hilarious, in my opinion. So, maybe we should push to make that happen. All right, last little bit on measurement and observation, and we're going to wrap this up. Okay, so measurement and observation interconnectedness. Observer effect in physics. The act of measurement can influence the system being observed. In quantum mechanics, this is famously illustrated by the double slit experiment, where the act of observing a particle changes its behavior. Now, we discussed about the Chris Fields stuff, that's because of the entanglement, right? In order to make an observation, you have to become entangled with the thing that you're observing, which fundamentally influences it and it influences you, and you can't disentangle those two things, right? So it means that you can't make an observation that's completely objective in a sense. That's probably the easiest way to say it. Took me 50 minutes, but we got there. Okay. So the act of observing a particle changes its behavior, but this is not just at the particle level. This exists across all of the things, right? The act of observing the cup changes the cup. It collapses the wave function to be a cup, but still all of those processes, right? It's just, you can't disentangle that because you're entangled with it. Okay. Relativity theory. Measurement in relativity, both special and general, involves considering the observer's frame of reference. Time, length, and mass measurements are relative and depend on the observer's velocity and gravitational field. Again, this is getting into this entanglement, but just at a higher level now. We're at the special and general scales of things, right? Philosophical and cognitive aspects. From a philosophical and cognitive science perspective, measurement is not just a physical act, but also a cognitive one. It involves interpretation and understanding of data, which is influenced by the observer's mindset and theoretical framework, the models that you're running, essentially, right? So it's, I think what all of this just shows is that we can't disentangle ourselves from the things that we're observing, which means we can never really say that this thing is, without a doubt, this, right? Because we are always imposing something on that. It is us that is hallucinating it, right? Okay, so in conclusion, measurement is a multifaceted concept, obviously, that transcends simple quantification. It involves fundamental principles of physics, philosophy, considerations, and the inherent link between the observer and the observed. This complexity ensures that the exploration of what it means to make a measurement remains a rich and evolving field of study. So I find these things deeply fascinating, very mind-bending. Is there anything or any threads that you would want to pull on?
I don't know. I don't know what's going on with me on today's pod. I wasn't as alive as I usually am for some reason. Today was like I felt like part of the audience today, actually, listening. This is the first time I heard anything about a lot of this, actually, about the measurements thing. So I do find it fascinating. I just don't know how to elaborate on it. Like, this is it's pretty new to me, Roops, to be completely honest. Yeah, but it was very interesting. But if I have anything to add, I don't.
A measurement is an observation in a sense, right? That's like they're incredibly interconnected. They're sort of just like different ways of saying it, but that's what we're really finding. Like I think probably a way to say it is that we used to think that measurements were these objective things, but we're now realizing with all of this work that these different people are doing and what they're converging on is that even the measurements are subjective, right? They're not these objective things that we thought that they might be, or that we conceive them to be.
They're objective to... Are you saying that because we're hallucinating? It's occurring in this controlled hallucination?
Yes, but also on top of that, it's think of okay, one way to describe this is the universe or the world around us is this potentially infinitely complex thing, right? Even if it isn't, it's vastly more complex than and big, right? There's just so much more happening in it than within us. Okay. So we always have to approach it from some reference frame, from some viewpoint, which inherently biases what we're going to see, right? So the way you look at something kind of dictates what you see about that thing. And we don't have the means, we don't have a vast enough extent across the universe to be able to approach things from every possible direction that they could be approached to say definitively that that thing is that thing or whatever, right?
Right.
And so there's a whole bunch of stuff I'd love to get into, but you have this in category theory, you have the Yoneda lemma that says that what makes something what it is, what gives a thing its thingness in a sense, or what defines something as what it is its interrelation to everything else, right? And so because we aren't everything else, we're only a subset of other things. And then when we observe something, we are getting entangled with that thing. And so then it becomes related to us. So we see it relative to us. And by doing that narrows us in on a frame. But that isn't the only way that you could define that thing. That isn't the only way that you could see that thing. There is much more going on with that thing that you don't have access to because you're not everything else.
That's why I still think that we could say that these measurements are objective, because they're objective to us. They're objective according to our perspective on it, right? Because we can have measurements taken consistently throughout, different countries. Like, for example, height and weight, like centimeters and pounds, will be the same here as it is anywhere else in the world. So in a way, it's objective enough for our standards and our needs. Don't you think?
Yeah, but to fundamentally understand that our conception of objective is just a useful coarse graining for us to say it isn't fundamentally objective. It's actually subjective.
Right. Okay. Yeah. I see what you're saying.
So
yeah.
It's a lot to wrap your mind around. But again, I think it's really quite, it's mind expanding to try and conceptualize these things, to realize that let's just bring this all the way back to your cup example, right? When we first started talking about this. It's convenient for you to think that that's a cup, right? It's convenient for you to go, that's objectively a cup, right? It holds water, it does all this sort of stuff. But that's one way to look at that thing. There are many other ways, and different observers at different levels of existence or scales of existence, right? Or different extents within the universe will conceive that thing to be different. And there are many different ways to conceive of that. But like you said, it works. It's convenient for us to think that that's objective. Yeah. And that's because we are computationally bounded. And I think what's beautiful about all this work is it's illuminating to us that the universe is just vastly more complex and interesting. And that there's so much more to think and understand. And again, this sort of duality between trying to understand the universe better, but in order to understand the universe better, we actually need to understand ourselves better, right? Because that's trying to disentangle more about how much we impose on the universe, right? Or understanding what it is that we truly impose on the universe, because then that sort of, I don't know, by doing that, it kind of gives you it kind of helps you to develop a deeper understanding of what might actually be happening. And I think that it's very beautiful. And it's definitely changed, like trying to understand these things, not claiming that I do completely, or that, I don't even think it's possible for anyone to completely do it. It's definitely changed how I see things. It's made me a calmer, more understanding kind of person. I think it actually helps you to develop compassion. And it's a beautiful thing. But yeah, any comments? Did that last little bit make sense about how you approach reality defines what you're going to see about it? And because you always have to pick a way to approach it, you can't pick every single way to approach it. You could never truly know what that sort of thing is. You can only know what it is relative to you.
Absolutely. Absolutely, guy. I think that's a wrap. I think that was beautiful what you said at the end there, especially the part about you being more compassionate from beginning to understand some of these concepts. That's dope. I love that.
Yeah. It sort of helps one to break out of their sort of limited or very finite, very limited reference frame and sort of expand your space of what's your conception space or your worldview space. Like it's a way to expand one's worldview. We can often get caught in like this sort of, trap down into, whereas I find that thinking about these kinds of things and trying to understand them more deeply really is expansive. And it's fun to exist in a bigger space. It can be scary at first because you can get lost, and you can still get lost. Don't get me wrong. That happened today. But yeah, all right, we'll wrap it.
Ignorance is bliss, guy.
Yeah, in a sense, definitely. So yes, thank you very much. If you made it this far, thank you very much. We greatly appreciate your attention. If you have any comments or questions, or you notice that fucked up somewhere or didn't do something or misrepresented someone or something or didn't go into as much detail as you might like, feel free to comment. We have been active replying to comments this past week. We're going to try and do more and more of that. So thank you very much. Have a wonderful rest of your day, night, or week. And we'll catch you next week. Peace. Love you, guy.
All right. Peace, bro. Love you, guy.
Later. Bye.